So yesterday we took a look at how to use tangent ratio to determine angles. Today we'll look at using the tangent ratio to determine lengths, remembering the tangent ratio is one of three trigonometric ratios that can only be applied when you have a right triangle. So specifically, the tangent ratio looks at the lengths of the opposite and the adjacent as they compare to or relate to a particular angle. So the very first thing that we want to do is in our right triangle, in this case PQR, we want to identify which is the hypotenuse. So the hypotenuse, always the longest length and always opposite the right angle. To determine the opposite and the adjacent lengths, we need to decide which angle we are referencing. So if, let's say, we're going to reference angle R, so I might call that angle theta, reminding ourselves that theta is kind of like the variable for an angle. So if I'm deciding on angle R, then opposite angle R or angle theta is length PQ, and so that is my opposite, and adjacent or beside angle theta is length PR, so that is the adjacent. A mistake that students often make is they decide that QR is also beside angle theta, which it is. However, it's already been labeled and designated as the hypotenuse, and therefore it is not the adjacent. The adjacent and the opposite can only be labeled onto the legs of the triangle, or the two lengths that make up the right angle. Okay, so let's take a look at some examples, and we'll put them into context. So before we do so, a couple of terms to be familiar with. So if we have an angle of elevation, or sometimes it's also called an angle of inclination, what we're looking at is if I have, this is my eye. So if we imagine that our sight line looking forward is horizontal, and we're looking at a balloon that is floating in the sky, so we're looking up, the angle that is between our horizontal line of sight and looking up to the balloon is called our angle of elevation. Similarly, if we are looking down at perhaps, I don't know, a little bug on the ground, and we're looking down to the bug, that angle that is created from looking down as compared to the horizontal, that we call our angle of depression. So the key thing to remember is whether we're talking about the angle of depression or the angle of elevation, it is always going to be relative to that horizontal line of sight. Okay? So let's just make a note of that. So always relative to the horizontal line of sight. So let's take for example then that we have a tree, and we know that we've been able to measure that the distance that we are standing away from the tree is 12 meters. We also have a tool that we'll talk about soon enough that allows us to measure that angle of elevation, so that sight line to the very, very top of the tree, and we've measured that to determine that that angle is 48 degrees. So let's say that we want to determine than the height of the tree. So we can see that we have the height, which is opposite the 48 degrees angle, and the 12 meters, the distance along the ground, that is 12 meters. Obviously, we're also making a few assumptions here. We're assuming that the tree is standing at a 90 degrees to the ground, and that the ground is horizontal for that 12 meters where we are standing. So let's take a look at our ratio then. So we know that tangent of theta, we can start with our formula, is equal to the length of the opposite over the length of the adjacent. And let's fill in what we know. So theta, our angle, is 48 degrees. The length of the opposite is our unknown. We call it h for our height. The length of the adjacent is 12 meters. And at this point, it really just becomes solving a ratio or proportion. And so what some people might think of is that tan 48 is over 1. And what do we know about a proportion or two equal fractions is that cross products are going to be equal. So h times 1, or h, will equal 12 times tangent of 48 degrees. And we can put that right into our calculators, making sure though, of course, that our calculators are set to degree mode, not in radians or gradians. And if we enter that into our calculator, we find out that the height is approximately 13.3 meters rounded to the nearest tenth. Let's take a look at another example then. What happens if we are, say, standing at top of a canyon that is nicely almost rectangular in shape, and we've crossed a bridge, and we know that the distance across the bridge is 47.8 meters, and we know that the angle of depression, so here we are standing on the edge there, we know that the angle of depression to that bottom, we've measured that, and it comes out to 32 degrees. And we want to find the depth of the canyon. So let's take a look then. If we have tangent of theta, once again, is equal to the length of the opposite over the length of the adjacent, we can say tan 32, filling in our missing values. The opposite is d, our depth, and the distance across the bridge or across the canyon is 47.8. Again, setting it up as a proportion or two equal ratios, cross products are equal, and so d times 1, or d, will be equal to 47.8 times tangent of 32 degrees. If we enter that into our calculators as is, then we can see that the depth of the canyon should be approximately 29.9 meters. And we'll put that approximate symbol on, indicating that we have rounded our answer. One more example then. Let's say, for example, that we are in the street and we are looking at the top of a tall building, and we know that the height of the building is 72.4 meters. And here's the road. We're standing at the bottom of the road there, and we can see to the top of the building that the angle of inclination, again, remember relative to the horizontal, angle of inclination is 75 degrees, and I'd like to know how far apart, what is the distance from me to the building. So let's take a look then. So once again, we have the opposite of the angle and the adjacent. So again, we're looking at the tangent ratio. So tan of theta is equal to the opposite over the adjacent, or tan of 75 in this case is, and the opposite we have this time, that value is 72.4 meters over the adjacent that we're missing, which is D. When we set up our proportion, take a look. It's set up differently than our previous two examples. When cross products are equal this time, we can see that D times tan of 75 degrees will be equal to 1 times 72.4. To isolate our variable, we need to divide both sides by tangent of 75 degrees, and tan 75 divided by itself is just 1, so then we're left with D is equal to 72.4 divided by tangent of 75. Again, entering that into your calculator. In degree mode, we can determine that the depth is, the distance away from the building is approximately 19.4 meters. So, at this time, please complete the assigned questions for topic 2 in your textbooks.